Hello students, welcome to EPG Pathshala. I am Dr. Nidhi Tidwania from Manav Rachna International University, Faridabad. Today we are going to discuss about a module gas chromatography applications under paper chromatographic techniques. The learning objectives of this module are to understand the scope of gas chromatography, to give an overview of the types of analysis, to explain applications of gas chromatography in pharmaceuticals, food, flavors, fragrances, environmental analysis, chemical, industrial, forensic science, petrochemical, modified analyzers, cosmetics, etc. to learn about advantages and disadvantages of gas chromatography. Gas chromatography or gas liquid chromatography, GLC or GC, is a technique which is used for separation, identification and quantification of components of a mixture of volatile substances. It consists of a flowing mobile phase, that is, generally inert gases like helium, argon, nitrogen, etc., an injection port which consists of a rubber septum through which a syringe needle is inserted to inject the sample. The injection port is maintained at a higher temperature than the boiling point of the least volatile component in the sample mixture. A separation column, that is the stationary phase, an oven and a detector. The principle behind GC is selective partitioning between the stationary phase and mobile phase inside a column, followed by sequential elution of separated compounds. Very minute compounds of a substance, that is parts per billion concentrations in gaseous samples, or picomoles of a substance in 1 ml liquid sample, can be measured with the help of gas chromatography, but it is often required that the sample must be measured in comparison to a sample containing the pure suspected substance known as a reference standard. Characteristics of analyte. To be suitable for separation by this technique, the compound should have thermal stability, that is, what is in general substances that vaporize below 300 degrees Celsius temperature, should be highly volatile and have low molecular weights. The samples are also required to be salt-free, that is, they should not contain ions. The scope of gas chromatography is unlimited. We can analyze wide variety of samples of complex nature, including liquids, solids, and permanent gases. Gas chromatography is of incredible use in identification and quantification of the components of thousands of compounds covering environmental and industrial samples, pharmaceuticals, petroleum, polymers, forensic science, food and beverages, etc. The application is further extended according to choice of columns, detectors, system modules, and use of hyphenated techniques such as gas chromatography, mass spectrometry, GCMS, gas chromatography, Fourier transform, infrared spectroscopy, GCFTIR, etc. GC can be used for all the three types of analysis. For qualitative analysis, by comparing the retention time or volume of the sample to the standard. Retention time is defined as the absolute time taken by a sample to show maximum peak after injecting. Retention volume is defined as the volume of gas required to elute about half of the solute through the column. For quantitative analysis, we should measure the peak area or peak height of each component. The purity of a compound can be checked by comparing the chromatogram of the standard and the sample. The instrument used to perform gas chromatography is called a gas chromatograph or aerograph or gas separator. Gas chromatogram is the graphical representation showing peaks of separated compounds on the basis of retention time or volume. You can see a chromatogram where the sample has been separated into different components showing peaks of different heights and area. It is necessary to measure the peak area or peak height of each component to analyze the components quantitatively. For the well-resolved peaks, both peak height and area are proportional to the concentration of the component. Pharmaceuticals. To provide drugs that are safe and effective, accurate analysis is needed and gas chromatography is very useful for this. Gas chromatography is used to analyze residual solvents in both raw materials, that is drug substance, and finished products, that is drug product. Knowing the amount of which compound is in a given sample gives a huge advantage in studying the effects of the drug on human health. In fact, pharmaceutical analysis generally involves two steps: separation of the compound of interest and quantitation of the compounds. The better the separation, the easier is the quantitation. With the help of GC, routine analysis of few drugs is a matter of few seconds. A few examples are in determining the levels of metabolites in body fluids like plasma, serum, urine, etc. Quantification of related substances and volatile impurities. Quality control and analysis of drug products like antibiotics, for example penicillin, antivirals, for example amantadine, general aesthetics, for example chloroform, ether, sedatives or hypnotics, for example barbiturates, etc. In drug assays, purity of a compound can be determined for drugs like atropine sulfate, clove oil, stearic acid, etc. It has many biopharmaceutical applications, including urine drug screens for barbiturates and for ethylene oxide in sterilized products such as sutures. Foods, flavors, fragrances. Foods comprise a complex mixture of components, and food analysis requires efficient methods of separation with high sensitivity or specificity of detection. Flavors and fragrances are, in general, complex but homogeneous mixtures of volatiles requiring high efficiency techniques for their analysis, such as gas chromatography. As such, or combined with mass spectrometry, that is GCMS. A few examples are analysis of foods like carbohydrates, proteins, lipids, vitamins, steroids, drug and pesticide residues, trace elements, etc. Quantification of volatile organic food products, food adulteration, detection of toxic components. In food flavors and fragrances, there are few other examples, that is, monitoring legislation for food products, formulation of controlled diets, controlling the formulation during the product development, detecting the changes in food during storage and processing, analysis of alcohol beverages, analysis of various solvents in food preparation, analysis of dairy products such as milk, butter, cheese, etc. That is, with the help of rancidity, analysis of residual pesticides, herbicides, etc., analysis of fragrances and flavors, fatty acids profiling of fats and oils, fatty acids methyl esters, FAME analysis. In environmental analysis, gas chromatography is used in detection of pollutants such as pesticides, fungicides, herbicides, aromatics, chlorinated compounds in air, water, and soils, etc. Industrial environmental protection applications include stack and waste emissions as well as water discharges. Gaseous combustion products can be analyzed rapidly and accurately by gas chromatography and has become increasingly important to propulsion research. Air samples can be analyzed using GC coupled with flame ionization detector, that is FID, as it has more sensitivity and resolution. A few examples are ambient air and stack emissions monitoring, quantification of pollutants in drinking and wastewater, residual pesticides in agricultural produce, vegetables, fruits, soils, and drinking water, analysis of environmental toxins like dioxins, polynuclear aromatic hydrocarbons, polychlorinated biphenyls, that is PCBs, dibenzofurans, etc. Identification of unknown organic compounds in hazardous waste dumps, analysis of industrial products as well as identification of reaction products, pollution studies, and other kinds of environmental analysis. Chemical, industrial. There are numerous gases found in industrial process plants that are harmful should a gas leak occur, such as sulfur dioxide, hydrogen sulfide, vinyl chloride, monomer, benzene, 1,3-butadiene, and others. These gases may be highly flammable, highly explosive, and or highly toxic. Inhalation of these compounds can result in conditions like pulmonary edema, oxygen deprivation, or even death. Therefore, an ambient air monitoring system is required in industries by state and federal regulations. GC helps in determination of the product content, determination of purity, monitoring production processes, etc. Thus, it is very important in assuring the quality of products. Gas chromatography is used to detect organic acids, alcohols, amines, esters, and solvents. It gives reliable and accurate analysis of fugitive gases. Measuring toxic substances in soil, air, and water. It helps in detecting the steroid drugs used by the athletes in international sports competition. Steroids administered to the animals in traces. It is able to retain and separate some compounds that cannot be separated by other methods, for example, geometrical isomers. Forensic science. Gas chromatography is used extensively in forensic science to identify and quantify various biological specimens and crime scene evidence. Blood alcohol analysis test is used by law enforcement to determine if a driver was unlawfully driving or operating a vehicle. Also, to check whether person has taken the prohibited drugs in the body, and to identify which fluids and chemicals are present in the body. Thus, use of gas chromatography has now become well established and widely recognized in the forensic science. There are three different areas identified: forensic pathology, crime scene testing, arson investigation. Forensic pathology. Gas chromatography has been applied in forensic pathology as it is useful to determine which fluids and compounds are present inside a human body after death. This is vital in determining whether or the person was intoxicated either from alcohol or drug abuse at the time of death, or indeed whether there is any poison or other harmful substance present in their body. Of course, this is imperative knowledge to determining cause of death and possible motive and culprit in the case of foul play. Crime scene testing. Since gas chromatography can accurately identify substances with no error margin, it can be of great use in crime scene testing. The blood samples or fiber samples from clothing or other materials found at a crime scene can also be tested with the help of gas chromatography. This allows scientists to pinpoint exactly what and perhaps who was present at the scene of the crime, and may even allow them to develop theories or where the suspect or victim had been before, depending on the variety of material found. Arson investigation. Because fires are most often started using a cocktail of hundreds of different compounds and components, and these vary in terms of strength and concentration, it can be hard to determine what exactly started the fire. Also, many compounds are dissolved during the fire, and therefore, gas chromatography can be a low-cost alternative of detecting flammable liquids on site. Petrochemicals. Petrochemical analysis often requires highly complex mixtures resulting in hundreds of closely spaced peaks which necessitate efficient resolution capabilities. In petrochemicals, GC is used in both monitoring of petroleum refining and finished product testing, for mapping of oil reserves and tracing of reservoirs, etc. Used for natural gas analysis or refineries, gasoline characterization and fraction quantitation, etc. There can be a range of detectors which can be used in GC. The choice of detector will depend on the analyte and how the GC method is being used, that is, analytical or preparative scale. First is flame ionization detector, that is FID, which is used in light hydrocarbons in refinery streams. Second, thermal conductivity detector, TCD, used for inorganic gases in ambient and workspace environments. Third, pulse induction, PI, metal detectors, that is PID, used for analysis of BTX, unsaturated and aromatic compounds. Fourth, foot pressure detector, that is FPD, used for organosulfur compounds in streams and oil residues. You can see a diagram of flame ionization detector, FID, and it is used to analyze light hydrocarbons in refinery streams. A few examples are ambient air as well as Workspace monitoring for common gases such as carbon dioxide, nitrous oxides, H2S, CS2, benzene, toluene, xylene, that is BTX, etc. Analysis of refinery gases for optimization of refining process. Analysis of finished products such as liquefied natural gas, naphtha, gasoline, aviation fuel, gas oil, lubricants, grease wax, asphalt, etc. Analysis of underground and undersea hydrocarbon reservoirs for commercial viability of exploration of such resources. Gas chromatography offers a very powerful compound-specific alternative to the infrared methods for hydrocarbon analysis. High temperature, that is 325 to 450 degrees Celsius GC, HTGC, has been developed and used for components of high molecular weight in crude oil, etc. Earlier, the maximal column temperature of conventional GC was around 325 degrees Celsius, and the analysis was limited to hydrocarbons with carbon number less than about 35, which limits the GC applications. Modified analyzers. The post-combustion gases, which contain only a limited number of gas components, can be analyzed through traditional CEMS, continuous emission monitoring systems. Using continuous gas analyzers monitor while the gas composition prior to combustion, where typically many more gaseous components exist, can be analyzed by determining flare gas emissions. This can be achieved by gas chromatographs, which are capable of multi-component analysis, including calculation of the calorific value in a refinery. A gas chromatograph monitors the impurities in the hydrogen recycle stream and improves the product quality by minimizing the C3 and lighter content in the finished product. The liquids extracted from natural gas are used as feedstock for many other petrochemical processes. The ethylene plants uses ethane and propane as a feed, and isobutane is used in a refinery's alkylation unit. Gas chromatography is used in numerous processes throughout the natural gas liquids NGL plant and play a critical role in optimizing the distillation tower operation and assuring that each of the product streams meets these specifications. In ammonia plants, commercial products such as nitrate fertilizers and smelling salts are produced. GC monitors for unconverted carbons and complete removal of carbon monoxide in an ammonia plant. For optimum synthesis conversion, it maintains hydrogen to nitrogen ratio in ammonia plants. A gas chromatograph will help a methanol plant to minimize losses of methanol, monitor for unconverted carbons, and minimize impurities in the methanol product stream. Power generation solutions. GC could help to reduce emissions and operate the combustion turbines and natural gas fired burners more efficiently. Gas chromatographs provide a reliable online measurement of natural gas heating value, that is BTU or CV, for more efficient control of turbine and burner combustion. For measuring composition, gas chromatography can help in accurate determination of fuel gas composition and enable the combustion turbine operation to be most cost-effective and efficient, where NOx emissions are minimized. For measuring warp index, the variations in the warp index can cause turbine damage. To ensure that no damage to the equipment results from operating on low or mid-range warp gas, gas chromatograph can provide the required analysis with accuracy. For measuring hydrocarbon dew point, turbine damage in power plants due to flashback can be avoided by measuring hydrocarbon dew point. Gas chromatography can be applied to cosmetics in measuring the amount of volatile chemicals used in cosmetics. Advantages of gas chromatography. There are numerous advantages of gas chromatography. With the gas chromatography analysis, it is very fast because of the highly efficient nature of the separations achieved. There is high efficiency leading to high resolution and a very high precision. It is a micro method and requires only very small samples, that is less than 1 ml with little preparation. Very difficult separations, chiral and other positional isomers may also be carried out using a combination of oven temperature and stationary phase chemistry, that is polarity. This is a rugged and reliable technique which has been well established with extensive literature and applications. The cost of instrument is relatively low and its life is generally long. Disadvantages of gas chromatography. There are lot of advantages, but the applications are limited by some of the disadvantages. GC is limited to volatile samples only. It is unsuitable for samples that are degraded at elevated temperatures, that is thermally labile substances. It is not suited to preparative chromatography like HPLC. Gas chromatography requires MS detector for analyte structural elucidation, that is characterization, as most non-MS detectors are destructive. So students, let us summarize what we have learned in this module. Firstly, there is unlimited scope of gas chromatography. Gas chromatography can be helpful in both qualitative, quantitative analysis as well as checking the purity of the compound. There are wide variety of applications of gas chromatography in different fields like pharmaceuticals, food, flavor, fragrances, environmental analysis, forensic sciences, etc. Gas chromatography has thus numerous advantages and a few disadvantages as well. Thank you.